Okay, well here's section 6.6, derivative and integral practice for transcendental functions. Transcendental functions are ones that cannot be written and factored and that type of thing with whole numbers in front of, well, I'll tell you what, let me just explain that when we get into class, because it'll be easier to show you then. Okay, but we want to practice differentiating and integrating functions involving logs, exponentials. We want to get ready to do some application problems, and we need these tricks in order to be able to do it. It's a pretty short little lesson, so hang tight, listen with me, let's go. Okay, almost nothing new today, but you want to keep those previous notes handy. You're going to do lots of problems with natural logs or exponentials. Lots of problems with base B logs or exponentials. Okay, we really want to get this material cemented in your mind, so take advantage of this time. There should be lots of review, lots of opportunities to make sure that you've got this stuff without any trouble. Okay. Integrating trig functions. It says the integral of tangent x dx is either the negative natural log of absolute value cosine x plus c, or the natural log of absolute value secant x plus c. Let me let you think about that one for a minute. If you drop down, it says the integral of secant x is the natural log of secant x plus tangent x plus c. And we need to figure out why that happens. Now we have to be a little bit creative, and we have to know, we have to think about like trig identities, and we have to think about tricks that we've used on other things. So let's start with our tangent one. Trig identity for tangent changes it to sine x over cosine x dx. And then using our u substitution, u equals cosine x. So then du is negative sine x dx. So then I don't have a negative, so it'll be a negative du equals sine x dx. So now then this becomes the negative integral of 1 over u du. Okay? Oh, we know how to integrate that. That's not a problem. Equals negative natural log absolute value of u plus c. Don't forget that. But my u value is cosine x, so that's negative natural log absolute value cosine x plus c. Okay, well that gives us the first one. What about the second one? Okay, well we've got to think back to our rules with logarithms. If you have a negative in front, that can be the same thing as that negative 1 exponent. And if you do 1 over cosine x, that is the same thing as secant x. So, there we go. That gives us our second one. Both of them checked off. All we did was use identities and use substitution. Not a problem. Then we get to this next one. And I mean, secant, I could go to 1 over cosine, but that doesn't work nicely like the one above because I don't have a sine in there. And I end up with this secant x plus tangent x thing over there that's kind of a problem. However, if you remember, when we were working with trig identities, or with some other things, that there were times when we had to multiply by something that wasn't there. It's just like converting a fraction. If I want to convert 1/5 something over 10, I have to multiply by 2 over 2, even though I don't see it. I just have to get there. So if I know, if I knew I had 1/5 and I wanted to get to something over 10, I would know to multiply by 2 over 2. Well, if I see secant x, and I know that I want secant x plus tangent x, let's try multiplying by it. Let's change this. Let's make this the integral of secant x times secant x plus tangent x all over secant x plus tangent x. Right? That makes sense? Okay. So not a big deal on that. All I'm doing is technically multiplying by 1. It's almost like multiplying by the conjugate if you had, a plus or minus there. We're just multiplying by 1. We knew what we needed to come up with, so we put it there. All right, so now then, I've got the integral, and I'm going to distribute through on the top and get secant squared x plus secant x tangent x all over secant x plus tangent x. Under your side, do your u substitution. U equals secant x plus tangent x. And du, derivative of secant, is secant x tan x. Derivative of tangent is secant squared. And lo and behold, that is your numerator, isn't it? All right? So you've got that whole thing there, and that works perfectly. That makes this again become the integral of 1 over u du, which is going to be natural log absolute value of u plus c, and then you'll plug that back in. Natural log absolute value, your u was secant x plus tangent x. Let's see. And there you go. It's all verified. These are your remaining trig identities. Yes, they have to be memorized. Yes, you need to know these. At the very least, you've got to know how to derive them, just like what we did. And I'm not sure on that last one that you would think to always come up with that. So be sure you know how you get them. Pause it, get those written down, and that's it. We'll work. It says not due Monday. We'll discuss that in class. Bye.